Hello everyone and welcome to LeetTutorials. Today we're going to be solving valid palindrome. The question gives us a string s and wants us to return true if it's a palindrome or false otherwise. A palindrome is defined by the question as a phrase after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters. It reads the same forward and backward. Alphanumeric characters include letters and numbers. Let's take a look at an example string that is a valid palindrome according to this question. In this example, the string starts with a capital A, which we can convert to a lowercase one. Then comes a B, followed by a comma and a white space character, which we can both ignore because they're not alphanumeric. Then comes a 1, which is an alphanumeric character, so we should consider it. 1 is followed by a capital B, which we can convert to a lowercase 1 and include. We can also ignore the colon that comes after because it's not alphanumeric. Finally, we see a lowercase a. As you can see, the final string, which does not include any non-alphanumeric characters and has lowercase versions of the uppercase characters in the example string, is a valid palindrome because it reads the same forward and backward. So we need to return true in this case. In our solution to this problem, we're going to be combining the steps of ignoring non-alphanumeric characters and checking for the palindrome property as opposed to the one I have shown in the previous example. This will enable us to improve over space because we're not going to be using an auxiliary string to store the alphanumeric characters. Instead, we will use 2 pointers to keep track of the characters from the beginning and end of the string. This is important because in order to check for the palindrome property, we need to have access to the alphanumeric characters situated at the same place with respect to the beginning and end of the string and compare these two characters. So initially, our left pointer will point to the beginning of the string and our right pointer will point to the last character of the string. After that, we need to make sure our pointers point to alphanumeric characters, and if they're not, we need to shift them until they do so. Afterwards, we need to check if the lowercase versions of the characters are the same or not. If they're the same, we're going to simultaneously shift the pointers by one place, else we can immediately return false because it violates the palindrome property. We're going to be performing this algorithm until left and right pointers coincide or surpass each other. If we don't return false until that point, we have a valid palindrome, and now we can return true. Let's apply this algorithm to the previous example. Here, L denotes the left pointer and right denotes our right pointer. Initially, the left pointer is going to point at capital A and our right pointer is going to be pointing at lowercase a. Since their lowercase versions are the same, like this, we advance. Now, left pointer is going to be pointing to B and the right pointer is pointing to a colon. So we shift right until we see an alphanumeric character, which is capital B. Since these two characters are the same letters, if we convert the capital B into a lowercase 1, we advance our pointers by 1. Now right points to 1 and left points to a comma. We shift left until we see an alphanumeric character. So we shift left up until 1. Since left and right coincide, we can now return true. Let's see how this algorithm works in another example. Our left and right pointers are going to be initialized to the beginning and end of the string. So left points to R and right also points to R. Since left and right point to the same character, we advance. Now left points to A and right also points to A. Since they're the same, we also advance. Now left points to C and right points to C as well. Then left points to this E and right points to this white space. Since this white space character is not alphanumeric, we shift right by 1, where we end up at an A. Since E and A are not the same characters, we do not have a valid palindrome. So in this example, we need to return false according to our algorithm. This approach has a time complexity of O of n, where n is the length of the string, and a space complexity of O of 1. This is because we're doing a linear time traversal on the string by using 2 pointers and moving them toward each other, and we're not using extra space. Now let's code this solution. First of all, we're going to be initializing our pointers. Then we're going to be looping over the string until these two pointers coincide or left surpasses right. That's why we use a left less than right comparison. Then we need to shift our left and right pointers if they're not pointing at an alphanumeric character. And I'm going to be using a Python function called isAlNum in order to check for alphanumeric property. If our left pointer is not an alphanumeric character, then we're going to be shifting the left pointer to the right, so we increment it. And likewise, for the right pointer, we're going to be shifting it to the left. But we need to check if left is less than right in these two while loops, since in this state of the algorithm, left and right will go out of bounds if the string is only composed of non-alphanumeric characters, and we will try to access these characters at the places these pointers are pointing at. So we're going to be checking that condition in these two while loops. After that, we're going to be checking whether these two characters are the same or not by converting them to their lowercase versions. And if they're not the same, we need to return false. If we don't hit this if statement and return false, we need to advance our pointers by one place. And finally, if left and right do not coincide or left surpass right throughout this while loop, it is certain that we have a valid palindrome, in which case we need to return true after we break out of the loop. And now I'm going to be showing you how we can write our own isAlNum function. I'm going to be naming this function isAlphanumerical, which is going to accept a char and return true if the char is alphanumerical and false otherwise. First of all, I'm going to convert char to its lowercase version, and then check if char's ASCII code is between the ASCII codes of A and Z or between 0 and 9. For that purpose, we can use the ort function of Python. This is going to check if our char is between A and Z by comparing its ASCII code to the ASCII codes of A and Z, and we're going to be doing something similar for the numerical part. And now we can return this Boolean value, which is going to give us whether the char is an alphanumerical character. And I have modified this palindrome function to use our isAlphanumerical function. I'm going to be submitting now, and I hope this works. As you can see, our solution works and is pretty efficient. I hope you found this video helpful, and if you did so, please like and subscribe. I really appreciate your support a lot, and I'll see you in the next one.